All right, so we're going to do something a little different next week in lab for Lab 9. So that's the purpose of this video, is to give you a heads up about what we'll be doing, why we're doing it, and what the expectations will be for this lab. What we're going to be doing is typically called a hackathon, and in particular we're going to be hacking some code that demonstrates collisions. So for lack of a better title, we'll call Lab 9 the Great Collision Hackathon. I should probably say a little bit more about what a hackathon is. It's kind of interesting. I was reading an NPR news article the other day, and there was actually a hackathon sponsored around the subject of Ebola in Massachusetts, in Boston. Not that Ebola is in Boston, but they were trying to gather high-tech students who were in engineering or one of the medical fields to try to develop or improve the sort of crazy hazmat suits that you see people wearing when they carry off the Ebola victims. And I can see why you'd want those suits to be more appealing. A lot of people are afraid now of health workers in Ebola-infected countries. They're sending healthcare workers away, claiming that there is no Ebola in their households. And the idea would be to make these suits more attractive so that healthcare workers are not just dismissed when there's been a case of infection. But a hackathon is essentially an event that happens over a few days, sometimes less than that, sometimes more than that. But the idea is to try to improve some process or software or product. So many high-tech firms, such as Google, Microsoft, etc., sponsor these hackathons with the intent of hacking into something that's important to their organization to make it better. Typically, teams form and work together during the time of the event, and they submit their presentation, their product at the end of the event, at which time it's judged by a panel. There's often prizes given for the best submissions. But why do a hackathon? The idea is really that this is something that gets done in large organizations very often. And it's quite likely that at the end of your academic career, you will be in some sort of high-tech organization. And so you should always have in the back of your mind, number one, how can I improve what we're doing here? And number two, how can I work better with my colleagues to improve my organization? So we're really kind of modeling the outside work world by having you get involved with a fairly low-level hackathon. So what will you be doing? You'll be forming teams of either 3 or 4 people, so you'll be working with either 2 or 3 of your colleagues. And the idea will be to take some VPython code that's already been written, and in the allotted time, to take that code and make it demonstrate elastic collisions and inelastic collisions better in some way. So that's the theme, is collisions, and more specifically, elastic versus inelastic collisions. Most hackathons start off with a brief presentation on the theme to just get you going. So I'll say a little bit about collisions. I won't say much. There's a whole lot more in your textbook in Chapter 10 if you're interested. But basically, what happens in an elastic collision is 2 objects run into each other. They bounce off of each other as if they had a spring in between them, and bounce away from each other. And the idea is that whatever energy the 2 objects had to begin with gets stored in some sort of elastic spring system while they're interacting, and then that elastic potential gets totally restored to the 2 objects afterwards. So the idea of elastic is, number one, bouncing, but But number two, it's all about energy conservation within the system. So collisions, if they happen in an isolated system, do allow for momentum conservation, but often they lose energy in the process of collisions. An elastic collision is very special in that both momentum is conserved in the isolated system, and number two, no energy lost in the collision to the surroundings as well. As I mentioned, elastic collisions are fairly rare and unusual. It's much more usual to have energy get lost to the surroundings during a collision. And we call those types of collisions inelastic. What I'm showing here is a very drastic inelastic collision known as a totally inelastic collision. Totally doesn't mean you lose all of the energy in your system. What it simply means is that the two objects completely stick together during the interaction, so that at the end of the collision you now have one big mass, whereas you started with two smaller masses. Okay, so that's really the idea of inelastic to begin with, is a stickiness rather than a bounciness. But as a consequence of that, the system has to lose some energy to make the sticky business happen. I think that's all I'll say about the collisions themselves. Like I mentioned, Chapter 10 in your text says a lot more. But let me get into how teams will form, because we'll start off next Tuesday simply with team formation. And how it'll work is you'll come in and self-identify into one of three levels, depending on your comfort with VPython and the computing environment. The idea is that you'll be in a team of either one of two types. You'll either be mixed in as level 1s with level 2s in a group of 3 or 4, or you'll be mixed in as a level 2 person with a level 3 person group of people. So the mixtures are going to be one level difference between the group members, and depending on your comfort with computation, your team may be expected to do more coding than a team at a lower level. So the highest level of team is level 2 members mixed in with level 3. The lowest level is level 2 members mixed in with level 1. So what we're hoping to achieve by this mixture is that within each team, you'll be helping each other to grow in some way. If you're uncomfortable with the coding, you're going to have to go to your more skilled team members and get some help from them. If you're more skilled, hopefully your lower level team members will be pushing you to do something that you haven't tried yet. So just real quickly, what is a level 1 person? Here's kind of a brief description. You just are not comfortable with VPython. You get really confused with the syntax, the logic, the variables, you name it. So what you'll be doing in your team is basically trying to understand the simulations that your team develops. So you'll be running the code, perhaps changing some of the parameters within the code. You'll be documenting the code to explain what it's doing. So you will have to reach a level of understanding about the code. Maybe not writing it, but trying to reach that understanding. You, along with your two teammates, will also be documenting the collisions that you witness. So you'll be taking screenshots of the graphs that get produced and trying to interpret those graphics. Okay, so your main job is to run things and pester your level 2 colleagues about your understanding. Your level 2 colleagues, we'll call them level 2 mixed with level 1. You're fairly comfortable with the coding, but you may not know a lot of the so-called bells and whistles that you could build into a program to make it run more smoothly, to make it look more interesting, etc. So within your group, you're going to be mostly responsible for creating code, and improving upon what's already existing to make it look more creative, to run nicer, possibly putting things into the scene that make it look interesting. We'll just put it that way. I'll leave it open at that. So you will be expected to work with your level 1 colleagues to describe what's going on and make any changes to the code that they request. Okay, and the final level is level 3. We're really talking here about computer science majors, as well as people who may have had some experience with computer games in the past in terms of writing code for those games. So what I'll be expecting of a team that's a level 3 with a level 2 mix is to revise the code in some way to make the collisions in 2 dimensions instead of 1. And I'll just leave it at that there are multiple ways to do that. I'm just going to leave it to you guys to figure out what are some creative ways to turn your one-dimensional collisional code into something 2-dimensional. Your level 2 colleagues, again, will be running the code mostly, documenting it, making suggestions, and potentially incorporating some creative things into the scenes. But you as a level 3 person are going to take the code and do something different with it by turning it into 2 dimensions. So what will you actually hack? There are 2 snippets of code already that we're going to provide on D2L. They are running pieces of code, and yes, they do both forms of collision. So your goal will be to figure out how to improve the code. And we'll just leave it like that, but improvement means documenting the code, writing comments in it, as well as running the code and making sure that the physics looks right. Okay, so just a kind of a summary about the expectations of the 2 teams. Level 1/level 2 team, what you'll want to turn in is code that is thoroughly documented with comments, a document with graphs showing what happened in different types of collisions. You'll want to change some of the initial conditions of the carts before you start the experiment to see what happens. And you will want to incorporate some bells and whistles to make the scene either more interactive with mouse clicks, keyboard strokes, or potentially just have interesting things riding on the carts. I'll leave it up to you as to what makes a bell and whistle. Level 2, level 3 expectations, again, better have that code thoroughly documented with comments. Turn the collisions into something with a 2-dimensional aspect. Interpret the graphs that come out of various experiments with the code, and add some bells and whistles. So what will you be judged on? Obviously the code to start off with is working, so we expect working code, but we will be reading through for the thoroughness of the documentation. So what you'll be turning in is your working code, a report describing the experiments you did with the code, explaining the graphs that came out, and trying to understand whether the graphs demonstrate realistic collisions as you understand them. So we'll refer you to Chapter 10 to try to understand that. Quick note about the timeline. You'll have a full week to work on this. Next week in lab will be Lab 9, so you'll be working in your teams then. And we'll have a brief time where we'll have to have exam 3 the week following, so skip that week. But you will have the Tuesday before Thanksgiving break. November 25th is a Tuesday. And you'll be working on this, continuing your teamwork through that day. and we won't expect anything to be turned in until the Monday after Thanksgiving. Okay, so that's a real quick brief overview. Be sure to ask your instructor if you have questions, and we'll see you next Tuesday.